Hi everyone, thank you for attending this webinar. My name is Vikram and I work for GL Communications. I'm joined on this webinar by my colleague Mike Yang, who's our senior engineer, and he'll be talking today about telecom protocol simulation across all networks. This is a very popular solution that we offer. We're also joined on this webinar by my colleague Sanjeev, who's based out of our India office. We are GL Communications. We are based in Gaithersburg, Maryland, USA. We also have a development office in Bangalore, India, and we also work with sales representatives all around the world. We've been in business for now over 30 years. We are a telecommunications consulting company, and we also manufacture telecommunications test equipment, both hardware and software. And our bread and butter is the ability to test across all different types of telecom networks. So whether it's your, plain old telephone system, whether it's any analog network, whether it's a T1 or E1 network, or whether it's Ethernet or SONET or wireless, 2G, 3G, 4G, 5G, and so forth. We can basically test across the full spectrum of different telecommunications technologies. We literally have products that cover all of these different domains. So we're very versatile, and we have a large customer base. Every customer is a little different. They always each customer is interested in a certain protocol or a certain type of test or a certain application. So we are a very broad company when it comes to the telecom test and measurement sector. Our solutions can analyze these networks. We can monitor them. We can visualize the data as it's going through. We can capture the data. We can store the data. We can emulate the data. One item missing here actually is emulation. We can emulate traffic flowing across these different networks. And actually that's the major topic of today is emulation. We can simulate a lot of different protocols. Okay, so first of all, why do we need protocol simulation? So as you know, our whole world is now connected more than ever before, right? So whether it's T1, E1, whether it's Ethernet and IP networks, whether it's wireless, 2G, 3G, 4G, LTE, 5G, connectivity is everywhere. And basically that means that there's a lot of network infrastructure out there in the world. And this network infrastructure needs to be tested under various conditions. So you may be interested in loading up a certain element in the network. Or you may be interested in testing a certain network element for compliance. Maybe compliance to a specific RFC standard or a certain specification. You may be testing network infrastructure after it's been upgraded or after there's been some change or some cutover. So network infrastructure is always being swapped in, swapped out, upgraded, and so forth. So you need to constantly test these networks. Besides the actual network infrastructure, which is carrying the telecommunications protocols, you also have the end user equipment. So what is that? That could be cell phones, it could be analog phones, it could be radios, handheld radios, it could be VoIP phones. All of these types of end user equipment must also be tested under various conditions. Your computers and so forth. So the end applications as well as the network infrastructure all needs to be tested. And so because of that, network engineers need a versatile platform for simulating all these vast protocols and testing all these vast devices. So what network engineers come to us, they usually come to us with something that's very easy to use, It has a comfortable graphical user interface where they can point and click, run tests, start tests, stop tests, get the results quickly, run tests over and over again, get reports, immediately identify and start troubleshooting faulty network equipment and user equipment. Now, we also get a lot of customers that need scripting capability. If you need to run, like 100 different tests over the course of a week or a day, you don't want to have to do that manually through a GUI. You'd rather want to use some sort of scripting capability. Maybe you want to use some built-in scripting language that we offer, or maybe you want to use your own scripting language like Python or C# to automatically run your tests over and over and export all the data to a simple file so you can quickly see the results. So we get customers that need both the GUI, and we need customers that need scripting capability. And all of this is a great segue into one of our best-selling products, which is called Message Automation and Protocol Simulation. MAPS is the acronym we use. And Mike will talk more about MAPS starting on the next slide, but I'll briefly just mention that we have sold this to service providers, equipment manufacturers, defense contractors, government agencies, pretty much anybody you can think of that is interested in generating traffic on a network. So that's basically anyone. Anyone who's interested in generating traffic and seeing how that traffic is handled and received and forwarded and responded to. That's what MAPS can do for you. It's a very powerful platform. And with that, I'll go ahead and stop talking and turn it over to Mike. And Mike will dig deep into the MAPS platform on the next slide. Thank you.
Okay, thank you, Vikram, for the great introduction. And thank you for everyone for joining the webinar today. So the focus of today's webinar will be on our MAPS platform or the MAPS framework. So we're going to provide an overview of MAPS, explain some of its key features and capabilities, and then we'll also examine some of the inner workings of MAPS and see how it may suit your testing needs. So what's MAPS, right? MAPS is basically a generic framework that we developed for the generation of telecom protocol messages and the transmission of bearer traffic. Development for MAPS started back in 2008 with SIP and ISDN as the first protocols that we targeted. And since then, it's grown to more than 30 plus protocols that we simulate, as you can see in the graphic on the right here. The framework is, so besides the protocol simulation, this framework is also used in some of our other products that we have at GL, such as the Packet Expert Ethernet Tester. So it's a very powerful framework with lots of capabilities. You can customize it to do lots of different things. So we think it's a very good framework for testing different protocols. So it has a script-based architecture. This allows us to really easily customize test scenarios. For the scripts, we give you full access. You can customize the call flow. You can customize any of the protocol messages according to its standards. So you can modify parameters in the messages, customize it however you want. We'll get more into that as we go into the webinar a bit more. MAPS also gives you the ability to automatically generate lots of calls, so as a bulk call generator, and it's also good for feature testing for all of these protocols. There's a centralized control that we provide in MAPS. So if you want to run MAPS in multiple instances or multiple locations, we have a centralized graphical user interface where you can control all of the different nodes from one location. There's also a API that we provide for all of the protocols that you see here, which lets you run tests through third-party automation frameworks. And so, as we said, it's a common framework that we use for all kinds of protocol simulation. So what we're seeing here is the SIP and the SS7 simulator. And as you can see, there's a common GUI involved. They all look the same. Once you're comfortable with one instance of maps, you're basically comfortable using all other instances. The same is true for the API or the CLI component. There's one common API or CLI that's being used that you can use to run your own tests, run your own test cases, and so on. Okay, so what are some use cases, right, for maps? So basically, we can simulate endpoints, such as a SIP or an analog phone. We can perform bulk call generation. We can do feature testing. We can simulate different network elements. And let me go back to the previous slide here. We can simulate different network elements, such as what you see here for the wireless networks, 2G, 3G, 4G, and the latest one, 5G. We can set up the entire core network. We can set up a live wireless network, meaning we're able to use a radio to broadcast, whether it's 3G, 4G, or 5G. You can connect real live devices into our network, into our simulated network, and then you can place voice calls, send SMS, browse internet, basically everything you can do with a real phone on a real network. Aside from that, we can also do location-based services in these wireless networks. We can simulate emergency calls for 911, either using the legacy protocols such as CAMA or the latest next generation 911 protocol, which relies on SIP. And then lastly, conformance testing is also available through MAPS. We have conformance test suites that are available that performs the test as defined by the standards. So lots of different use cases for MAPS. So it's a very complete product. And now let's go into a bit more into how the software works. Okay, so MAPS is basically it's a piece of software that runs on Windows systems. That includes Windows 10, Windows Server. It can also run on virtual machines and in the cloud. And I believe we're bringing support for containers as well in the cloud. So it has a graphical user interface, right, that allows users to easily run tests. You can modify different call parameters and view the results very easily through this GUI. There's also the API component, which is it's a client that you can run on your own systems, and that can be run on Windows or Linux. But the main Maps component is a Windows based solution as of today. Okay, so the software covers the basic protocol message generation as well as traffic generation. Traffic meaning voice, sending tone, sending digits, things like that, or sending for the wireless network, generating GTP traffic where you're generating data traffic in the network. And the load generation capability of this software-based version, so it sort of varies depending on your PC specification. As one example, if we're talking about a SIP-based simulation, so the MAPS SIP software, that simulator can generate about 2,000 concurrent calls with RTP traffic for carrying voice just on a standard i7-based PC. Alternatively, we have a dedicated appliance, which we call the MAPS HD platform. That has a dedicated SmartNIC that greatly increases the number of RTP traffic that we can handle. And we'll talk a little bit more about that in another slide. So for traffic generation, we support traffic generation in TDM, IP, and wireless domains. We support basically all of the industry standard codecs. Some of the more popular ones, such as G711, ALAW, MULAW, G729, AMR, narrowband, wideband, and EVS codecs. So we can generate voice, digits, tones. There's also fax testing capabilities in TDM and in IP. We can do video testing, and then in the wireless networks, we can do voice call testing, SMS, as well as simulating data. So we can simulate, for example, a real mobile device browsing the internet from the simulator. Okay, and then this is the high density appliance that I talked about earlier. This relies on a smart NIC to generate the RTP traffic. It can come in a rack mount version or the portable version, which we're showing here. And basically, you can generate up to 32,000 concurrent RTP sessions for one of these systems. So there's a 4-port smart NIC on here, and basically each port is capable of producing 8,000 sessions. And this can easily scale up, so you can have multiple of these systems stacked together. We can have a centralized GUI that controls all of the systems. So you can easily scale up to hundreds of thousands of concurrent calls with this framework. Okay, so now let's go a little bit deeper into the MAPS architecture. We'll talk about the 3 major components here and how it all works together to actually generate calls. So basically, there are 3 layers here. There's the scripts, messages, and profiles. So the script is basically the, you can think of it as the state machine that drives the call. So all of the call flow information is programmed within that script. The script is a proprietary language that we develop, but it's easily readable, and users can modify those scripts to do their own, perform their own kinds of testing. So the logic is contained in the script, and then messages are the actual protocol messages that we send or receive for every protocol. So MAPS has a inventory of these message templates, that's what we call them, which it loads from the drive when we are actually transmitting a message. And these messages are completely customizable. So you can go in there and edit pretty much any parameter in the actual message. And I think that's what really makes MAPS a powerful tool. There's a lot of capability in terms of customizing the messages and the call flows that you're performing. And then the last part is the profiles. So the scripts and messages we try to keep as generic as possible. So specific information for a call, such as which number you want to call. If you're emulating a subscriber, what's the subscriber information, authentication parameters. Those things are stored in profiles. Okay, and let's dive a little bit deeper into the scripting. So as I mentioned earlier, the scripts are written in a proprietary scripting language, and they're basically the state machine for generating calls. You can think of each script instance as a single transaction or a call. So if you're using the GUI to, let's say, place 500 calls, what you're really doing is starting 500 instances of the scripts. So these scripts run very efficiently, so we're able to scale up to high number of calls while still maintaining the flexibility that you have for modifying the scripts to do your own kind of call flow. And of course, it's possible to make your own scripts, but you almost never have to, because for every MAPS product that we provide, we have all the necessary scripts provided right out of the box. And in this picture that we're showing here, this is the script editor that we provide with the MAPS software. It gives you all the different actions that are available in the script So you can easily go in there and define your own script, modify some of the capabilities, and so on. Okay, and then this is an example of the message templates that we store on the drives. So there's really two versions of templates that we have. One is based on, one is binary based, which is used in protocols such as SS7 as an example, and in all of the wireless networks, 3G, 4G. So those for those binary based messages, we give you a message editor, so you can go in there and add or remove optional parameters, elements for the message. You can modify pretty much any of the parameters in there, right? So as an example here that we're showing a information element for a registration request message in the, I think this is a 5G protocol that we're showing here. So you can go in there, you'll see that there's an optional parameter option. So you can pick and choose any of the available options here, add it to your message, or of course you can remove these optional parameters. And then for every parameter that you add, you can go in there and modify the value directly within the message template. So that's the capability of the binary-based messages. And on the right-hand side here, we have an example of a text-based message template. So what we're showing here is for a SIP invite message, which is basically a text-based protocol here. And again, you can modify any of the parameters that you see in this message template. You can add stuff to this template that maybe that's not really a valid message, but you can add it into the template as sort of a test of your network. And then you'll see that there are dollar signs here for variables. So these are variables that are available in the script. So let's say the username is a variable in the script. When we actually run the call, you'll replace this parameter with the value of this parameter that's defined in the script. Okay, and then lastly, the profiles. So the profile stores all of the information, all the information for a particular call, right? So because we try to keep the scripts as generic as possible, a lot of the information specific to a call are exposed in the profile. And what we're showing here is a user equipment profile that we have for the 5G network. So you'll see information such as the MZ, which is the identification or the identifier for a subscriber. You'll see the MZ number that you can program here, network parameters, authentication parameters. So all of those are stored in this profile. It's stored as a XML file, and this gets loaded during the script execution. Okay, so when the script loads the profile, it's basically taking in all of the parameters that's defined in the profile here, and then we run that with the script. It's possible to add your own values to the profile. So if you want to modify a parameter that we don't cover out of the box, you can add your own parameter in here and have that be modified through the script. And then you can add additional profiles into this list. You can add up to thousands of different profiles here, and essentially each profile you can think of as a unique endpoint that you're trying to simulate. Okay, so we put all those three layers together, and then we can make and receive calls basically. So on the left side, we have a call generation screen. So you'll see here to actually make a call, we are defining a script which has the .gls extension. So we're picking a script and we're picking a profile that we have defined. And then you can click on the start button to actually make the call. So when you start the script, the script has the call flow predefined in it. So when you start the script, it'll go through the call flow. It'll know what messages to expect to receive, and then it'll know how to respond to those messages. In this case, we're seeing a example SIP call here. So we're sending the invite. So in the GUI, there's a message sequence here that you can see that shows you the entire transaction of your call flow. And then you can select each message, and it'll give you a full decode of that message right within that GUI. So you can see as the call progresses, we're sending the invite, we're getting the trying and the ringing back, and then finally the call connects. And so this is basically how you make a single call to the call generation capability. So you can define multiple scripts right in this window. You can use the same profile, or you can use different profiles. You can set the number of iterations that you want to run the script. So you can run it one time, 10 times, or you can run it infinitely. Those are options all available right within the GUI. You can add hundreds or hundreds of different scripts right in this call generation window. So opposite the call generation side, we also have a call reception capability. So in this case, instead of us invoking the call, we are receiving messages into our system, and then we're automatically invoking a script to handle that message. So it looks similar to the generation side, except in this case, this script, this SIP call control script, got invoked because a invite message came in. So we took a look at the invite message, looking at the content of the message, and then from here we extract the parameters that are relevant to us. So we're examining where the invite is going to, so the user that is trying to reach. If this user here matches with one of the users that we have defined in one of our profiles, we're going to start the script and then load that profile. And then the script again will have all of the call flow information programmed in, so it knows how to handle the message and then how to respond to it. Okay, and then there's traffic options available that you can select in your profile. So in this case, you'll see that in the status section, we're saying that we're doing a send file. There's different traffic options that you can select in your profile. So once a call is established, we can just automatically send a voice file or play some digits, play a tone, so on. And then in protocols such as the CAS protocol, where we simulate a two-wire device, right? This is especially important. So we want to establish a call and then play tones back and forth to verify that there's actually a audio path flowing between the two devices. Okay, so aside from the call generation and the call reception capability, we also have a load generation capability. So this allows us to generate high volumes of calls, with just a few clicks. So in here, you'll see that you can define the scripts, again, that you want to use to run your call. You load the set of profiles that you want to use. Then you have options to define a load pattern that you want to use to generate your calls. So let's take a look at this fixed pattern here that we are showing here. So what this means is we're trying to place calls at a call rate of 100 calls a second. So 100 calls a second, meaning we're starting 100 instances of our scripts every second, with each script representing one call, right? So we're generating calls at this call rate, and then it's going to continue to generate this call until a max number of call is satisfied. So in here we're saying, so this example, we're showing multiple scripts here, with each script having a limit of 100 active calls. So this number can be adjusted to have to be hundreds or even thousands of max active calls. So we'll generate calls at a defined call rate until that max number of active calls is reached, and then we'll sustain that number of calls until a total number of calls to generate parameter is satisfied. So in this example, it's saying that there's no limit here, so it'll just continuously generate calls. But you can have thousands of calls defined here, and we'll just keep generating calls at your defined call rate until that total number of calls is satisfied. So the test duration, the number of calls per second, all of that stuff is customizable right within this GUI. So once the calls are up, we have statistics to show you how the calls are going. You can see the total number of calls that you made, how many calls are still active, what's the pass or fail rate with these calls. The pass or fail criteria is defined entirely within the script, so you have total control over how you want to determine whether a test is successful or not. There's also a pie graph here that we show you of how many calls completed, how many passed, how many failed. We also keep a log of the messages that we transmit or received. So this is all the number of all the counts of the messages that we send or receive. If there's a retransmission that happened for any of these messages, we'll show you a count here as well. Just provides an easy way to monitor, whether you have error responses that happen during load generation. So this is keeping account of every message that's either sent or received. There's also user-definable statistics that we can provide that are programmed within the script. On the left side here, we're showing you voice quality statistics that we're collecting within the scripts. We consider these as a custom or user-defined statistic. So we're bringing out the information for all the calls that we generate, how many calls have a good call quality, how many calls have average quality, and so on. So all those metrics are collected and displayed within this window. Same for the graphs. You can keep account of. You can define your own graph of to show information like how many calls were successful, how many calls have good quality score, how many calls have bad quality score, and so on. And here are some basic logging features that we have within the application. So there's 3 different logs here. There's an event log, error log, and then captured errors. So the event log is just normal events that happen within the script. Everything that you see in this log is populated by the script directly. So there's a command in the script here that you can log information. So some of the stuff that we're logging here, for example, in this event log is the link status, the authentication parameters that we're using to send to create a call, and so on, how the call is going, whether it's successful or not. And the second login of error log, this is also logged within the script with a error log command. It's similar to the event log, except this is where you want to log in case of a reception of a unexpected message. If there's any errors that occurred in your script, this is where you can log that event. And then the captured errors is basically system level errors that happen. So for example, if the script tried to open a port that's unavailable, things like that will be shown in the captured errors tab. Okay, and then for every call that we make, we can also generate call detail records, and that information can get stored as a CSV file. So we actually do this as part of our Net Surveyor web solution. So for example, if we're using the MapSip simulator to generate lots of calls, for each call that we generate, we also create an entry into this CSV file that shows the information like if the call was successful, how long the call was up for, if there was an error in the call, what's the reason for that error, right? Why did the call not complete, or why did the call maybe disconnect prematurely? So things like that we store within this call detail records. Our Net Surveyor web application picks it up and displays all of this information in a nice graphical user interface. So it's basically a database that we provide with a front-end web GUI that you can go in and see all the details of all the calls that you've made. This again is completely customizable right in the script, so you can pretty much log any information that you want right from the script. Okay, so that was the basic components of the Maps GUI. And now we're going to talk a little bit about the remote capabilities of maps. So essentially, we have a centralized GUI that we can use to control all of the maps systems that we have set up in different locations. So you can see here, there's this is a remote controller that's controlling the different nodes within a LTE core network that we're showing here. So we're simulating different nodes in the core network. All of those nodes are running on a different PC, but this is a centralized way of controlling all of those systems. So it's a common GUI where you can choose which load you want to access, where you want to place the calls from, and so on. So you can have multiple of these remote clients connecting to a single server, or you can have a single server connecting to multiple clients. So very flexible in how you can do this. The same goes for our API control. So we have APIs available in Python, Java, Tickle. C# is also available, but that's kind of not used as much as the other languages that we're listing here. But essentially, those protocols, we provide an API for you where you can run on your client, and then that can connect into our map servers. So you can actually, using those languages, those APIs that we provide, you can construct your own call flow, and then you can run your tests from your own automation framework. And we actually have a lot of customers who do this, especially in the case of Maps SIP and then Maps CAS, where we used to simulate analog phones. Actually, a lot of the customers use the API to control the entire call flow. So in that case, the API gives you full control over how you can set up a call. And it actually lets you define the exact call flow that you want to perform step by step. So the API exposes sort of low-level functions, in that case, low-level functions where you can control, let's say, what message you want to send, what message you want to receive, right within a API in a language that's more familiar to the users. And then here we're showing you an example of a SIP call flow that's done in Python, right? So the API component, so sort of the idea to setting up a call is similar to the GUI. So you're defining a script that you want to use, you're loading a profile, and then you're running that script. But in the case of the API, right, you can use existing scripts that are already available in the GUI and use the same profiles that's already defined in the GUI. And then in addition, you can pass in parameters directly from your Python client to modify any of the call flow. So you can load up, let's say, a profile with certain subscriber information, but then on the fly, you can change things related to that call. So let's say you want to make a call with a different codec than the one that's defined in the profile. That's something you can do right within your Python application through our API. The window on the right here is showing you the CLI window for the map. So it's basically a server that we're running on the map system. And then this server is taking in commands from the different clients, such as the Python one that we're showing here, from Python or the Java clients that you have running your code. So this is basically showing you a log of the commands that came in. Okay, so I think that sort of wraps up the different components of the maps framework. And so now we're just going to wrap it up with a few words on the latest maps product that we have, which is the 5G protocol simulation framework. So you'll see here, everywhere where you see a little GL icon, so this is basically where we're simulating that component in a 5G network. So we're able to provide a end-to-end 5G simulation, basically, for the 5G standalone architecture. So you can perform feature and functional testing as well as load testing to our application. So for example, we can simulate massive numbers of UEs and then load it with voice traffic using the HD platform that I mentioned earlier. You can also simulate user plane GTP traffic at up to a very high rate, I believe up to 40 gigabits per second. And we can also provide a physical G-Node B, and then along with our IMS core simulator, where again, we're simulating all of the components here within the IMS core. So in this case, we can actually register 5G devices into our core network, and then we can perform voice calls over 5G. We can do SMS again, and then we can, simulate data traffic, or have the real device actually browse through the internet as if it was an actual live network. Okay, and I think that will reach the end of the webinar.
Thank you everybody for attending.